Hey all, today we are going to continue talking about probability, and we are going to make an addition to our addition rule. So in the last lesson, we talked about the basic addition rule for two events that were mutually exclusive. That means they couldn't happen at the same time. But what happens when we do have events that are not mutually exclusive? We can still use this addition rule, but we have to add this little piece. So if we were looking at a Venn diagram of these two events, A and B, for them to be not mutually exclusive, for them to be not disjoint, that means there is some overlap. There is this space in the Venn diagram where these two events have some elements in common, meaning you can be in A and B at the same time. And because of that, when we add these probabilities together, we are going to be adding some of the things twice because they're both events. And so we subtract away this overlap. This overlap is this part, this place where you are in A and B. So we have this survey done of college students. Some of them live on campus. Some of them are in a meal program, and some of them do both. And so if I did a quick Venn diagram, it's not something that's required, but it's sort of a helpful visual, and it could look as awful as mine, or maybe a little bit better. I am using a tablet. So I am going to do R for residence hall and M for meal program. And so we have 42% of our students are living in a residence hall and on a meal program. And so in my Venn diagram, that's this piece. And so there is 42%, so 0.42 of our students are in that part of the Venn diagram. We do have 56% living in a residence hall, but 42% of them are already accounted for in this overlap portion. And so we are going to say in this portion, there is 0.56 minus 0.42, which is 0.14. 62% have a meal program, but 42% of them are already over here. And so 0.2 are right there. And so if we want to know the probability of living in a residence hall or having a meal program, eating on campus, we can add those probabilities together. And then subtract away the overlap. So we have 62%, or I'm sorry, 56% that live in a residence hall, 62 that have a meal program, and we would subtract away the 42% overlap because we're counting those 42% twice. And so we get probability of 0.76. Probability of randomly selecting a student on this campus and them living in a residence hall or having a meal program is 0.76. The other way that we could come up with that is by using this Venn diagram. We have 20% of our students that have just a meal program, 42% that do both, and 14% that live in a residence hall. So if we were to actually add those three up, 0.2 plus 0.62 plus 0.7 or plus 0.14, we would get the same result. So there's kind of two ways to do this. We can use our new addition rule or our updated addition rule, or we can use a Venn diagram to sort of help us figure out our likelihood of an event happening. we've already sort of calculated these by using the Venn diagram. The students who live off campus, that means they're not in a residence hall and they don't have a meal program. Actually, I didn't calculate that yet. Those are the people that live in this area of the Venn diagram. They don't qualify to be in any of the pieces of the circles because they don't live in a residence hall and they don't have a meal program. And so all the probabilities in this scenario need to add up to 1. And so if I subtract this 0.76 from 1, I'm going to get 0.24, which is the probability I randomly select a student who lives off campus and doesn't have a meal program. So probably a older student who lives in an apartment and does their own grocery shopping. Someone who lives in a residence hall but doesn't have a meal program, that's these people over here. They live on campus but don't have a meal program, so maybe they live in a campus apartment and they do their own shopping and cooking. So we've already calculated that part. There's 14% students do that, a 0.14% chance of randomly selecting a person in that category. So I want to do another example of this for our drivers who are not doing the right thing by driving while intoxicated. So there's a couple ways to test to see if a driver is intoxicated. They can do a breath test or a blood test. Sometimes they'll do both. So we have non-mutually exclusive events. We have some overlap. For our breath test, I'm going to say BR, and our blood test BL. 22% get both tests. 36% get a blood test, but 22% of them are already in there. So we'll do 0.36 minus 0.22 and get 0.14. 78% get a breath test. We'll subtract out our 0.22 because they're already accounted for and get 0.56. And so if I want to know the probability that somebody gets a test, that means the probability of getting a breath or a blood test. I can do the probability of getting a breath test, add the probability of getting a blood test, and subtract away the overlap, the probability you get both. I can use my updated addition rule. We have these probabilities, 0.78 plus 0.36 minus 0.22. And you should know you did this wrong if you didn't subtract, because 0.78 and 0.36 are more than 1. Total probability can't be more than 1. So we get 0.78 plus 0.36 minus 0.22 is 0.92. So the probability of one of our randomly selective DWI suspects gets one or the other test is 0.92. Again, the other way to find that is by adding these three values together. So 0.56 plus 0.22 plus 0.14, and you get 0.92. All of the pieces in our Venn diagram that represent getting a test of some kind. The probability of getting a blood test or a breath test, but not both, well, that would be kind of just getting rid of this overlap. So you get a breath test only, a blood test only. We can add these two probabilities, 0.56 plus 0.14. Getting a breath test only and getting a blood test only are not are mutually exclusive. So we can just add them together and get 0.7. And then those folks that get neither test, they live in this area. We would do 1 minus our total, but we already have that total, 0.92. And that's only a 0.8 probability of somebody not getting either test done if they were stopped on suspicion of driving while intoxicated. So I have some practice problems for you. As always, I want to recommend that you do these on paper first. You can have me check your answers. You can have a discussion with me about them if there is one or more that you're not sure of before you put your answers into Edpuzzle. If you have any questions at any time, always ask. Take your time on these and good luck.